Workbook page 77, we're finishing up here talking about drawing inferences from data. So number one, in an effort to try to convince her mother that she is too old to join the intermediate swim class, Mira, who is 13 years old, gathers data on the ages of a random sample of members of the current intermediate swim class. The results of the data collected by Mira are displayed in the dot plot shown. So the first thing, they're asking the data are clustered between blank and blank years old. So cluster, we're trying to look for a group where we've got a lot of dots at. So a couple options here you could argue. I would probably say we've got in this area here would be our area we've got most of the things. The 10 you could include into that also would be okay. So we're going to say our clusters between either 10 and 14 or 11 and 14 years old. Either one of those would be acceptable. The book said 10 and 14, but again, if you said 11 and 14, that would be good also. Okay? So that's where we got a lot of people ages 11 to 14. So Mira is 13 years old. So based on the data collected, is it likely Mira will be able to convince her mother she is too old to join the intermediate swim class? And so the answer here we probably would say would be no. Mira's age falls within the area where the data are clustered. Okay, we've got quite a few 13-year-olds here, and we've got some 14-year-olds even. So it's not likely she's going to convince her mother she's too old to join the intermediate swim class. Okay? And again, even if it's possible she could be the oldest one, and it's not in this case, but say she was 15. Is she going to convince her mom that she can't go just because, well, she's 15. Well, there's a bunch of 14-year-olds. They'll probably be 15 before too long anyway, so if it's the swim level she needs, it's probably the class she needs to be in. Number two, the following dot plots show the amount of time it takes each randomly sampled student to complete two different sets of math homework problems. What is the mean time for each set of problems? So we have to figure this for both sets. Remember, mean is like an average, so we're going to add all the numbers and divide by how many numbers we have. Well, by adding the numbers, it's not just adding the numbers that are below the number line. It's looking at where the dots are. So in other words, we start out with two 27s. Then we have two 28s. Then we have three 29s, two 30s, and a 33. So you can either add all the numbers individually, 27 plus 27 plus 28 plus 28, and so on. Or you can look at repeated numbers. In other words, I have two 27s, so 27 times 2. I have two 28s. I have three 29s. I have two 30s. And I have one 33. Okay? Like I said, you can do it like this, or list all the dots out individually, and we're going to add those together. When you do these, if you're finding the mean, at a minimum, when you find the mean, I want to see your total and the number you're dividing by. Do not just put your answer down. Show me at least the total and what number you're dividing by. So adding these together should be a total of 290. And on this one we have 10 numbers or 10 dots. So we would take the 290 divided by 10, which is 29. So the mean time for set 1 is 29 minutes. In other words, on average, it took students 29 minutes to complete set 1. For set 2, we're going to do a similar idea here. We're going to have 4 24s, 4 25s, 2 27s. When you work that out, you'll get a total of 250. And we have 10 dots again. So 250 divided by 10, which would be 25. So for set 2, the mean or average time it took students, it'd be 25 minutes. So if we look at part B, make a comparative inference based on the mean values. Set blank of homework problems is more challenging than set blank. So based off the times that it took the students to complete the problems, we might say set 1 of homework problems is more challenging than set 2 because it took the students longer. On average, 4 minutes longer than on set 1 than set 2. Number 3, Sonia randomly surveys 26 7th graders to gather data about the amount of time spent each week using the internet. Sonia records the data in the dot plot shown. Sonia infers that on average most 7th graders use the internet a little more than 7 hours each week. So the first thing they want us to do is find the mean and the median. Mean, this is just the same process we just went through, and there's quite a bit of numbers there, so I'm just going to tell you guys the mean here is going to be 7.5 or 7.5 hours. The median is going to be the middle. If you look in the question, it told us that they asked 26 7th graders. So we should have 26 dots here. What that means is we're going to have an even number of dots. So 26 dots. If I split 26 in half as 13, I need to have 2 middle dots though, right? So 2 middle dots. 26 minus 2 middle dots is 24. If we split that evenly, split that evenly would be 12. So in other words, we would have 12 dots and then our 2 middle dots and then 12 dots above that. So if we count these off here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and now we're going to have 2 middle dots. So I can see I would have a 7 and an 8. Somebody says, how do you know whether to start at the top of the dots or the bottom of the dots? It actually doesn't matter. It'll come out the same. Okay, so our 2 middle dots would be the 7 and an 8, whether that be the bottom 7 and the top 8 or the top 7 and the bottom 8, whatever, it's all the same. So we're going to average the 7 and 8. So if you want to add the 7 and 8 together, would be 15, and then take half of that would be 7.5 or 7.5. So it ends up, doesn't happen a whole lot, but it ends up actually that our mean and our median are both the same. Her inference was that most 7th graders use the internet a little more than 7 hours each week. Well, mean is 7.5, median is 7.5. That sounds pretty good. A little bit more than 7 hours. Okay? So for part C, does that support her inference? We could say yes. Mean and median are both a half hour more than 7 hours, which supports her inference. We look at number 4. To determine the number of squirrels in a conservation area, researcher catches, tags, and releases 114 squirrels. He later catches 97 squirrels, finds that 33 of them are tagged. About how many squirrels are in the conservation area, round to the nearest whole number. So what we could do on a problem like this, we could actually do a proportion. We have 33 that are tagged. 33 are tagged out of 97, and we tagged 114. We're trying to find out how many there are altogether. So a proportion actually would be something like this. 33 tagged out of 97 is 114 tagged out of the total. So you may want to, when you're setting it up like this, you may want to write something like that off to the side, tagged in total, so you can keep track of what numbers go where. You could try to find a pattern with this. Something like this, if you can't find a pattern, instead of tagged over total, if we put total over tagged, in other words, we flip both of our fractions, reciprocal both of our fractions here, that would be another way we could do this. Because then the advantage of this is if I don't have a pattern, or if I don't have a calculator maybe to find a pattern, if I get the variable in the numerator, then I can say the variable is being divided and I can multiply. Okay, now there may very well be a pattern here. But this will always work. If you get the variable in the numerator, you can always work it out this way. And what should happen when you work that out? And that should come out to be 335. Make sure when you do this problem, when you get your answer, think about if it makes sense. He had 33 tagged, or he caught 97 squirrels. Earlier he tagged and released 114. So if he had 114 he already tagged earlier, our answer should be more than 114 for how many there are altogether. He didn't tag more than there are squirrels. Doesn't make sense. Number 6, we have a dot plots that show the number of calls 2 radio shows receive each day for a 10-day period. 2 shows are on at the same time. Question: which of the following inferences based on the median values is valid? Median is what we're basing this off of. So the median, if you look, the median here, we've got 10 numbers. Median for radio show 2 will be 44. Median for the other show, there are also 10 numbers, so that median would be 49. So that based off the median, then we would say radio show 1 generally receives more calls.